right, ladies and gentlemen, so today we're going to work on scatter plots and lines of fit. So we're going to be using the skills we've worked on so far this year, but we're going to use them in a slightly different way. And to do that, we've got a new skill to work on. We're going to talk about SID 6, which is representing data on two quantitative variables on a scatter plot and describing how the variables are related. So to do that, we're going to think about the vocabulary term of scatter plot. A scatter plot is a graph that shows the relationship between two sets of data. We have bivariate data. That bi, we know, means two. So we're talking about two types of data. And the scatter plot means we have a bunch of points. If we take a look at the bottom here, we see the types of correlation. We can have a positive correlation, we can have a negative correlation, or we can have no correlation between our data. They're not perfect lines. I can't just connect the dots here, but I can see relationships. With those relationships, I can draw lines of fit. Now, last year we called them best fit lines. This year we're going to talk about them as trend lines, because we're going to talk about a few different ways to write our trend lines. Trend lines are lines that approximate the data in a scatter plot. With this, we can do some linear interpolation. So we talked about linear extrapolation the other day. Interpolation is using lines of fit to predict values within the range of the data. So extrapolation is estimating data is outside the range. Interpolation is inside the data. We're using our lines of fit. So let's practice. Let's look at some examples here, and we're going to describe the correlation between the given variables. In your notes for the vocab, I'd also like you to have a sketch of those types of correlation, just as a reminder that if it appears to be going uphill, we have a positive slope. If it appears to be going downhill, we have a negative slope or a negative correlation. And if there's no pattern, we have no correlation. So to practice with this, let's think about some variables. The size of a car and the number of miles per gallon it gets, so how fuel efficient it is. Well, for this one, we would expect that this would have a negative correlation, because as the size increases, we would expect that the miles per gallon would decrease. So X is getting bigger, Y is getting smaller. That would be a downhill. Negative correlation. The number of letters in a student's first name and their GPA. Well, for this one here, is there any correlation? Should it matter how long your first name is? No. We can have any sort of range for number of letters in your first name, and that has no correlation. So for this one here, we would expect no correlation. This one here, studying and test scores. If I look at the data shows that there's a positive correlation. And what that means, my interpretation of that would be that as the amount of time studying increases, the score also increases. And I could draw in a trend line. Right now, using my skills as an 8th grader, I can draw in trend lines that are linear. But this one here almost appears to be a nonlinear trend line, which we'll talk about eventually. Last one, and this is out of the homework. I see the NBA three-point percentage compared to the height of the player. And this one here, I can see a negative correlation. What that tells me, my interpretation of that is that as height increases, the three-point percentage made decreases. Another practice problem here, and this is our last one, but it's a big one, and it's out of the homework. This is page 250, number 9. I'm looking at the data on Buffalo Bills' average game attendance in the years since 2000, and I want to use the points 5, 71,205 and 9, 68,611 to write the slope-intercept form of an equation for the line of fit shown in the trend plot, shown in the scatter plot. So this line of fit here was using these two data points. And that's one way to do a line of fit. We'll talk about a couple other ways eventually. But to do this, I'm going to use my skills of writing linear equations from key information. And that means that the first thing I need to do is I need to write the slope formula. I need to figure out my slope. As always, I have x1, y1, x2, y2. And I'm going to plug them into the formula y2 minus y1 over x2 minus x1. Switch over to blue today. Y2 is 68,611 minus y1, which is 71,205. And I'm going to divide that by x2, which is 9, minus x1, which is 5. My giant fraction becomes negative 2,594 over 4. Well, in this case here, I think using it as a decimal for my slope makes more sense. So if I divide my numerator by my denominator, I find a slope of negative 648.5. Now, what does that slope tell me? What's the meaning of this, my slope here? Well, that tells me that for every year past 2000, my attendance decreases by about 650 people. But now let's go back. I want to figure out where it's going to intersect the y-axis. I need to find that starting value. So I'm going to take my slope and 1 point, and I'll just use the first one here, to figure out the b value. I'm now thinking about y, let's use the same colors here. I'm thinking about y equals mx plus b. Using what I know, I have a y value of 71,205 equals my slope of negative 648.5 times my x value of 5 plus my unknown piece. Well, negative 648 times 5 is a negative 3,242.5 plus b equals this 71,205. Last step is I need to add 3,242.5 to both sides. 2.5, and I find that my b value is 74,447, 74,447.5. My linear equation, all I have to do is plug the pieces in, and let's squeeze it in right over here. Y equals my slope, 648.5x, plus my b value of 74,447.5. There we go, squeezed it in. So using those 2 points, I can write the equation of that trend line. Well, now let's think about predicting the average attendance at a game in 2020. And now we're going to predict this mathematically, not using what we know about the real world situation involving 2020. So what this tells me is I'm going to use that linear equation that I just wrote, y equals negative 648.5 x plus 74,447.5. And the average attendance at a game in 2020, well, 2020 is 20 years since 2000, so my x value is going to be 20. I'm going to have y equals negative 648.5 times 20 years past my starting time, plus that start value, 447.5. Order of operations tells me I need to multiply before I add or subtract, so I get y equals negative 12,970 plus my start value, and that tells me that I would expect 61,477.5. Well, I can't have half a person at my game here, so I'm going to round up to the nearest whole person. So I would expect 61,478 people. Mathematically, I would predict that that would be the attendance at a game in 2020. Well, now let's think about part C here. Can I use the equation to make a decision about the average attendance in any given year in the future? And the answer is no. There's lots of variables at play here. When we've talked about it in science, we talked about things that we need to control, those constants, and there's not things that we can control here. It could be that the Buffalo Bills have a really good season and then they're going to have higher attendance. It could be that they have a really poor season and attendance is going to drop. Or it could be something like 2020 where we have COVID and we don't even have games, so there's no average attendance to talk about. So this one here, as long as you can explain it, the answer is no. That it's useful in some situations, but it's not able to predict entirely into the future, especially as we go farther. That original data was from 2000, and that's a while ago when we're talking about attendance at events. So now your job is to get started on the homework here. Your homework is from page 250. It's numbers 4 through 10, 14 through 16, and 18 through 20. As usual, the key will be posted. Grade your own work and submit the form. This one here, nothing super challenging. As long as you understand how to find the slope of a line and use that to write the equation, you're good to go. There is one equation that you need to graph, number 10. Number 10 is kind of tricky. I gave a range of acceptable values because you're going to be drawing in that trend line. So do your best to be as accurate as possible, and good luck.